All right, so while not laboring in his secret identity of a mild-mannered software developer, Elliotte Rusty Harold lives in a secret mountaintop laboratory on a large island off the east coast of the United States with his dog Cream and two cats, Sheldon and Neutrino. He's an avid birder and entomology enthusiast. His most recent books are Java Network Programming 4th edition and the JavaMail API, both from O'Reilly. He's the creator of the XOM library for processing, XML with Java, the current maintainer of the Jackson XPath engine for Java, and Apache Maven committer. Oh, maybe you can let me know when 4 is going to come out. But we can talk afterwards. On a personal note, I first met Elliotte way back around 1999-2000 at the Software Development Conference, if you remember, the East Coast version. They were either in DC or in Boston. So over the years, I bought 3 of his books, which I dug out today, and 2 of them have been signed by Elliotte back in the day. This one's a small read here, the XML Bible. So, but I know these are older, but I'm glad I still have them. So, and then Elliotte, you spoke with us first time in June 13th, 2006, so almost 19 years to the day. And then I couldn't find the second time you visited with us, but that was on exception. So thank you for coming.
Before quarantine.
So thank you for coming out, and take it away.
All right. Thanks for that intro. Okay. Some of that's going to be a little more relevant than it usually is, including the entomology part. So let's see if I can find it. Here we go. Let's slip into view slideshow. So the ostensible talk tonight is some thoughts I've been having about shipping bug-free projects and how to write software that is essentially practically, if not theoretically, correct, and that users can use reliably and not get bothered by. So, and that is something that is surprisingly difficult. We rarely do it in this profession, but I think there are reasons we rarely do it. I think we actually know how to do it. The problem we have is that sometimes we don't do those things. I'm going to make an unusual disclaimer. This is not the one I've used for my presentations for the last 15 years or so. Today, nobody is paying me. I have no job. I'm either unemployed or retired. I haven't decided yet. So I can speak freely without worrying about getting called in for an uncomfortable conversation with my manager. Again, because I don't have one anymore. Yay me. So I can be a little spicier than usual, maybe. In the past, I have been tech lead and contributing engineer on multiple projects in the big tech world. I've worked for Google and Meta. I put at least one startup into the ground before then. I am the primary instigator, developer, and contributor of XOM, which at last count, when I wrote these slides in the GitHub repo, there were 28 open issues. None of them were bugs. That library has been around for about 20 years now. I am also not the original designer or creator of the Jackson XPath processing library, but I have maintained it for the last, I'm not sure how many odd years at this point, probably more than 10. I don't recall exactly. At last count, this has 13 open issues. None of them are actual bugs in the product. Some of them are things like you have to fix the CI scripts because Circle CI has changed their API again, which is something I'm going to explain in this talk why they shouldn't be doing. I'm an Apache Maven committer. I've written a few books. I am also a bug enthusiast. I like going out and looking at small creatures. Now, in this room, I'm going to assume everyone's a reasonably experienced Java developer. A lot of the things I'm going to say have nothing to do with Java. I'm a Java person, so my examples will be in that. I don't think there's anything really Java specific, though, about what I'm talking about. If you're in Python or Ruby or JavaScript, you know, all the same principles apply here. I'm going to assume everyone here has shipped products. You know, that this is not an audience of undergraduates, that you've done things more significant than homework problems, and that these are things that actually go out to other users, to the community in one way, shape, or form, be it deployed on a cloud server, on a web server, you know, shrink wrap software you sell at stores that no longer exist. Some of us are old enough to have done that. You know, stuff that goes into an app on a mobile phone, you know, all the usual, or just libraries that are used by other products. And I'm also going to assume that nobody here has entomophobia. And I will warn you, I'm not kidding about the bug phobia. There will be bugs. That's a bald-faced hornet there. I think it's eating a hackberry emperor that is, at this point, this photograph was taken, has mostly been consumed. This is a small group. I don't know how many people are watching online, but for those of us, it's a small room. So for those in the audience, feel free to chip in at any time. You don't have to raise your hand. You can if you want to, but you know, we've got a small enough group that as long as you're reasonably loud, you know, we can actually have some discussion. And this isn't a hugely long talk either. So you don't have to hold all your questions till the end.
If you do want to speak, let me know and I'll run this microphone up to you so that our friends on YouTube can hear you.
Good point. Thank you, Barry. Yeah. Okay. So, bug-free projects. Yes?
Your screen's showing.
Oh, that is true. It is showing. Why is it?
It's showing the desktop.
That's interesting. Let's see.
Not a question, but I have to mention that.
Yes, thank you very much for mentioning that. Let's see if we can get that fixed. Display. We had this working earlier. I don't know what happened to...
It was working a few minutes ago.
Yes, I did not notice screen mirroring. Let's see if we can do here. Mirror extend to... I don't know. Display settings. Is it maybe unplugged? No, it's because it's showing something. Does that? Oh, it looks like it stopped mirroring.
We just saw it.
Yes. Well, what can I say? Mac OS is not yet bug free. Okay, yeah. Okay, where there should be a brightness arrange. Where is the mirror displays hold option while dragging them on top of each other. So well, that just moved it to a different screen now, but that might actually not be horribly awful if I can just get it back to the let's see, slides. Now what happened?
Did we lose the...
I don't know. I'm still plugged in on the HDMI cable. I mean, I can just talk, so while we try this. This is not a code heavy.
There we go.
Okay, there. Well, okay, so we've got something going. Good. Okay, done. Okay. And then let's see if I can get back into, that's GitHub. I want, this is, Google Chrome quit unexpectedly. Wow, we've managed to crash Google Chrome. That's impressive. Let's see this.
Don't you love it? It's just...
I know, it's Murphy's Law.
At its finest.
Yes.
I
was gonna say it's worse. Well, it's bugs. Right. It's the little gremlin.
Yeah. And it's trying to.
Here it is. I got it.
Okay. So let's go view slideshow. All right, there we are. So there are two requirements for a bug-free project. I'm going to talk about both of them. The first one has been talked about a lot for decades. We've all heard a lot of these things before, but they're perhaps important to revisit. And that is to make the software right. To just, you know, get the bugs out, ship the correct thing, fulfill the requirements, find the bugs, write the tests, make sure the tests pass, all the usual things. We don't always do that. It depends a little on how many resources we have, how much time we have, how important it is to actually have bug-free software. It's not the same rules for a project that's going to be the software for mission to Mars as the software that's going to be, a new website for Firehouse Pizza. But so there's a cost-benefit trade-off here. But that's important. But that's number one, make it right. And then we have number two, stop. And I have increasingly noticed that it's number two where a lot of projects have the most trouble. They don't know when to stop, declare victory, and go home. So we're going to talk a lot about that. But first, part one, making it right. This is, I'm sure for a lot of folks, something of a review. Now, there are certain standard software development practices that we follow, practices of software architecture that help us to produce software we can understand, that we can ship, that does run and run reasonably effectively. So like one very important principle, keeps coming up again and again, is you want to separate your API from your implementation. This is especially important for anyone working on a library, but even if you're working on a monolithic single application that does not work as a library for anything else, often you can think of the individual components of the application as libraries for each other. That doesn't, I gotta add a caveat here, this doesn't mean a separate impl package. This is a mistake I see being made in a lot of places where they think that separating the API from the implementation means you've got an API package over here in Java, an impl package over there. And that isn't actually separation of implementation API. It's two different APIs in two different packages, one of which calls the other. And that's not incredibly helpful. Generally, you want to keep your API simple. You want to keep it minimal. You want to do the simplest thing that can possibly work. The less complexity you put in, the better, the less you're going to have to debug. General principle here, I'm sure you've all heard the acronym YAGNI. You ain't gonna need it. That is something you should always think. If you're uncertain, if you're ever thinking about a method, a function, a menu item, a preference, a new feature, default to not having it. If you discover that there's a need, you can always put it in later. And it's easier to add something in than take something out. So the smaller the software is, the easier it is going to be to understand, to document, and to implement correctly so that you can ship the bug-free product. In Java and some other languages, this means avoid public wherever you can. One of the things I don't like about a lot of IDEs is when they create code, they start by giving you a public class and public methods. Some things like main have to be public and equals and hash code, but most other things don't be, most other things shouldn't be. Defaulting methods to public is a mistake that IDEs like Eclipse and IntelliJ and others have made for multiple decades now. A lot of people got into bad habits because of that. If you start by making something not public and then make it public later, then you can always, do that. It's hard to go the other direction. I'll go off on a bit of a tangent here. Not all languages have this as an option. C++ does. Python doesn't. In Python, there's no public and private. You just sort of, there's the official rule that says, well, if you put an underscore in front of something, it's really supposed to be understood that it's private, and you're not supposed to call it. And we're all adults here, aren't we? Well, speaking as someone who has seen the sausage being made at some of the largest tech companies on the planet, with some of the smartest developers on the planet, and some of the smartest Python developers on the planet, no, we are not. And I have seen Meta and Google both ship software that is just in Python, written in Python, that is doing things and being used in ways it shouldn't be because of a lack of good software hygiene built into the language. So yeah, use private, use package protected. Limit your number of packages. This is another important thing for Java. Don't make things public to share them across internal packages. If you find yourself doing that, that probably means if you have a method in any place where the only reason that method is public is because you have another package in the same project that needs to call it. That probably means you should have one package, not two. And I saw this, for example, this happened in JDOM. This is back 25 years ago, where they've got input and output libraries and the model classes. And the input and output libraries need access to some of the internals of the element class and the attribute class and so forth. And therefore, some of the internal parts of those classes are public and shouldn't be. And that's why when I did XOM, I learned from JDOM, I said, just put them all in the same package. Input classes, output classes, model classes, one package. You don't need 3 different ones. And then you can keep a lot more things private. Ideally, one package is the answer. Now, those are just some general principles of software design, especially for Java programmers in particular. More general development practices, whatever language you're working in. Number 1, test-first programming. We've known about this for almost as long as Java has been around, since JUnit circa 1997-ish, 1998. I'm not sure exactly. I think I first heard about it in 1999 from Kent Beck at some conference whose name I don't even remember in Denmark. And it was like a light bulb went off. This is the silver bullet of programming. It is absolutely critical to writing bug-free code. Write your tests first, then write the code to make write a test first, write the code to make the test pass, no more. Make sure the test passes, write another test. I left out an important step there. Does anyone catch what step I left out in that cycle? Exactly. Write the test, make sure it fails, then write the code to make it pass. I have seen a lot of code where the tests were written after the model code was written, or they were written first, but they were not verified to actually fail, and they're not actually testing what they think they're testing. So if you start with the tests and you don't write any model code until you have a failing test, you are guaranteed extremely high code coverage. There'll be a few nooks and crannies where you have to write code for things like exceptions that shouldn't be possible, that you might not be able to get a unit test to touch. And that's not a big deal. But if you do test first, you get very good code coverage, you get very high quality software, you also get a better design. It really, really helps you to understand your APIs and to get the right method signatures. When you start by writing the code that calls the API rather than writing the API, you decouple the API more from the implementation because you're thinking about what each method needs to do instead of how each method is implemented or what algorithms it's using. So that's very important. Yes?
Can you talk about, at least newer for me, flaky tests?
Oh, flaky tests.
This is something that Trisha G. and Brian Demers, both from Gradle, have been discussing last few months.
Right.
And they gave a great presentation a couple of weeks ago.
Yeah, that's a very good question. Flaky tests, what to do about them, what are they? That's essentially a test that has non-deterministic results. It can be non-deterministic for a lot of reasons. For example, it often comes up in a continuous integration environment. For instance, I notice on GitHub, whether you're using Circle CI or GitHub Actions or some other continuous integration environment there with a Maven build, sometimes it just fails because it tries to load a dependency for the test and it gets a 403 error or 500 error from the Maven repository. It can also fail because maybe it's time dependent or it has randomness in the tests. I've seen one flaky test in Apache Maven lately that fails like 1 time out of 10 because it's comparing 2 timestamps and they're supposed to be different, but 1 time out of 10 they're the same. I guess the test in that case ran a little too fast and wasn't able to increment the millisecond counter before the test was finished. I'm not sure exactly. Flaky tests should definitely be avoided. You need to dig into each one to understand why it's flaky and how to fix it. Fixing a test that's flaky because your connection to Maven Central by the CI server is getting rate limited is going to be very different than fixing a flaky test that is flaky because timestamps come out the same on occasion. So it's worth digging into those and understanding why they're happening. If you have a lot of flaky tests, I might start by disabling all of them and then turning them on one by one and fixing them one by one, because it can be really troublesome when you have flaky tests, because then people learn to distrust the tests. And they say, well, the build is red, but I'm going to commit anyway. It's always red. And that's very, very dangerous. When I was at Google and they had very large CIs, essentially, that not quite, but effectively ran every test in the company for every commit. What they did was they had automated systems in place to notice if tests were flaky or builds were broken, and then to automatically exclude them from the global pre-submit checks so they would not block things. But that way you still knew that if your change to Google Docs broke Gmail, then you would get warned about it. As long as the Gmail tests, they have many test suites, I assume. I never worked on Gmail myself. As long as the Gmail test suites were mostly correct and mostly working most of the time, you'd be fine. So yeah, flaky tests are something to watch out for. Okay, now, assuming you've used test-first programming, you're probably not going to get this perfect. We're none of us perfect. We'll never get it all right. It is important to measure code coverage and to look at where you might have missed tests. And this is triply true when you're on any sort of legacy project that maybe didn't get built with really good test-driven development practices. This is actually how I ended up being the maintainer of Jackson, because Jackson already existed. I was using it in some of my things, and I noticed a bug or two. So I wrote a test for the bug, and then I fixed the bug in Jackson. And then I started running some code coverage tools. At this point, I don't remember what they were, maybe Cobertura, maybe Clover, maybe something else. And I noticed there were all these different methods that weren't tested, or they were partially tested. Maybe they weren't tested on the edge conditions. Maybe this branch of an if statement was tested and it wasn't. So I'd write a test for the untested part. And half the time, everything was fine. The test passed. Half the time, it wasn't fine. The test failed. I had found a bug. And I went through, over the course of, a couple of years, slowly adding one test after another for different untested parts of Jackson and pulling out more and more bugs, until eventually most of Jackson was tested and most of the bugs were squashed. So that's a very important tool, I think. It's not my first tool. My first tool is to write the tests first, but it's a good second tool. Where available, use conformance test suites. This is something I've done a lot for XML and XPath. These are standard specifications that are well-defined and that have normative test suites that you can apply and make sure your project handles. That's not going to be true for every project. Not everyone is doing something that involves implementing a very well-defined specification from an external body with multiple independent implementations. But if that is the world you're in, make sure you pass the conformance test suites. That's another good way to find issues. Another thing that's become increasingly important over the last decade or so is fuzz testing. This is where you just throw a lot of random input at your program and see if you can break it. This is especially important if you're looking for security holes in software or ways to, cause, to break into systems or to make systems go down or cause denial of service attacks. This can find some really nasty bugs some of the time. There are a lot of tools out there. They're useful for this sort of work. That's a little complicated. I probably should put this next one first. Static analysis tools like PMD and CheckStyle are also good for finding a lot of low-hanging fruit, easy bugs, like when you override an equals method and you don't override the hash code method, or vice versa, or your hash code method has the wrong return type, or you have, a private method that isn't used that you can just delete, or maybe you can't delete it, maybe it should be used, and the bug is that the private method isn't being used anywhere. That's one I see a lot. Unused code detectors, sometimes it means you can delete the things, sometimes it means there's something supposed to be using that code and isn't. But don't take these tools as gospel truth, and I wouldn't make them break the build. They do have a lot of false positives. So for example, in Apache Maven, we use a really weird custom dependency injection framework called Plexus. And PMD looks at our code and says, every class, you've got 12 unset private fields. Nothing ever sets them. Well, they're set via dependency injection, but PMD doesn't understand how our dependency injection works. So, excuse me, it just reports them all as unused. Finally, perhaps most controversially, avoid third-party dependencies to the extent possible. Every dependency is a liability. Every extra dependency you add is a new source of bugs and a new source of security holes. There's so many ways this can sneak in. This is something I changed over time in XOM for reasons of expediency. When XOM 1.0 came out, it depended on Jackson. It depended on the Xerxes XML parser. It depended on IBM's International Classes for Unicode. There might have been some other pieces in there. And from one release to the next, I kept chopping pieces out. So it can still use Xerxes, but it doesn't need it anymore. It can work strictly off the JDK. For the International Classes for Unicode, I just ripped that out completely. I replaced it with handwritten code to do all the Unicode operations and normalization rules and other things that XOM needed to do for its own purposes. So it no longer has that dependency. Jackson's a little weirder. It no longer explicitly depends on Jackson, but it essentially pulls in a fork of the Jackson code that is modified and hidden inside. But I'm only doing that because I'm also maintaining Jackson personally. So it now has very minimal dependencies. That gives me a lot more control of the build going forward, and it means I'm not locked into saying, well, there's this new security bug that is only fixed in ICU for J 13.5, so I have to upgrade to that, but that requires Java 11, so I have to upgrade to Java 11, which means I have to fix this other thing. I can decide when things upgrade or when things move. The fewer external dependencies you have, the better. Jackson, I think, has essentially no external dependencies. It does depend on the models. So if you want to use an XPath query against JDOM, for example, you have to have JDOM in your path. And the JDOM navigator that attaches Jackson to JDOM depends on JDOM. But the core of Jackson itself does not require JDOM anymore. That is a change I made. So that's development. Shipping practices. How do you actually ship the software? This can be tricky, especially if you are in a corporate environment, especially if you have to hit day and date, so you're not always going to get this. Number one, an extensive beta period. Don't ship until you're sure that it's right, because once you ship, it's really hard to change something if you ship not just a bug, but a broken API, a less than optimal API, something that is unclear or just ugly. Brian Getz has been making this point for the last couple of years very effectively. If you want to, Google Getz and peak of complexity, he's probably given this talk at a number of different conferences. This I watched the one on YouTube from DevOps. Don't be satisfied with a good enough product. The example he gives of this is object serialization and RMI. You know, back in the days of Java 1.1, they kept saying, okay, what do we need for object serialization? Add it. What do we need for object serialization? Add that. When they finally had something that met all the requirements, they had put all the pieces in, they found something that met their requirements, they shipped it. And it has been a horrible mess and source of security holes for the last, how old's Java now? 30 years? But Java 1.1 is a little younger than that, so maybe only the last 28 years. Because they didn't take the time to make it right. They just made it okay. And okay is not good enough if you want to avoid bugs. So you need, now, when I did XOM, I went through a lot of development releases, a lot of betas where I changed things. I had some things in it, for example, one that I still remember. You know, I had extensive protected setter and validator methods and other things that were designed to enable you to write subclasses that would only accept certain element names. And eventually, and I could have shipped that. But because I waited, I eventually realized I didn't need any of that. In fact, you could do all that with just basic setter methods. Some other things I read, like I think I had some iterator methods and some next element methods. And eventually I realized I didn't need them. So I took them out. And we're back to on my laptop. Okay, there we go. And now it's on both of them. Yay. We'll see how long that lasts. Anyway, beware the peak of complexity. Make sure you take the time to get it right, that you don't just force it out the door. Yes, Mike.
So first off the top of my head, that is the 6-month release cycle of JDK.
Where you have multiple previews and incubation process. Is that sort of a step in the right direction? Or
Yeah, I have thoughts about the JDK and the JDK release cycle. A 6-month release cycle is okay and is possible as long as you do not feel compelled to ship something before it is ready to hit the next release. That if something is not ready, it doesn't go in. Because we can't finish a lot of features in 6 months. Many features are more complex than that. They take more time. 6 months is barely enough time to finish anything non-trivial, especially in as complicated and legacy environment as the JDK itself. The problem with 6-month release cycles, the problem with really strong quarterly targets, the problem with aiming toward, you know, say Apple's WWDC. You got to be able to announce your new product at WWDC if you're an Apple engineer. It's not okay to release it a week later. Even if it's going to be ready a week later, you've got to release it then, is that they tend to give external pressures to force things out before they are naturally ready. And that is dangerous, and that is counter to shipping quality products. So I would love to avoid pushing things to force them to fit into a release cycle. Now, obviously, we don't want to let them last forever. We do want to ship. But, I mean, the dysfunction I saw at Google around this very issue was around the perf cycle. Every 6 months, everyone gets reviewed. Everyone has to show their progress, possibly a bunch of people going up for promo. And you want to make sure that you've got the shipped product in your perf packet. And if you ship it today, and as long as it's not so bad that the promo committee notices, then maybe you get the promo. But if you ship it next week after the perf packets go in, and maybe it's higher quality and you've stamped out the last bugs, well, you're not going to get the promo for at least another 6 months, which can cost you real money. So there is a very strong incentive to hit the date.
But a lot of times the next iteration of the preview, if you read the JEP for, it'll say we're going to do a next preview for additional feedback, from developers. So it's like, but they didn't make any changes. They'll say that sometimes. Sometimes there'll be a significant change. It'll be explicitly written. Other times it's like we're re-previewing without any changes. So in other words, I guess not enough developers have provided feedback.
Mm-hmm.
So they're looking to re-preview it again. And then when they're finally satisfied, then they'll finalize it. So.
Yes. People to look at your product, to try your product, and to use your product in advance of committing to it. Otherwise, they'll say, "I'll just keep using J&I because foreign function access or whatever they call that isn't finished yet. And I don't want to get into it before it is finished, before it is stable." In that case, you do the best you can. Maybe you can get the internal people to focus on it a little more heavily. Sometimes it's just giving your own brain, your own knowledge time to percolate and understand and think about things. So suddenly something will become obvious to you yourself that wasn't, 6 months ago.
It's,
So, yeah, take enough time. Okay, part 2, keeping it right. When you are done with the product, stop. Okay, I don't know if the camera can follow me, but I need to get something to drink, so I'm going to go steal the Diet Coke over here. I have a little bit of seasonal allergies at the moment. I apologize. This is the hard part. This is where a lot of products fail. Does anyone here follow Linux kernel drama? It's like a soap opera. Okay, one person, yeah. So you don't get to take part in this survey because you probably already heard this story. But for everyone else, this happened like at the end of May. So longtime kernel developer Keys submits a commit that rewrites the Git history of hundreds of files among making other changes, which is, he's just trying to fix some bugs and make some minor changes. It's a huge commit. It just, does all sorts of weirdness to Git. For example, several hundred commits that were written by people who are not Linus get assigned to Linus and say Linus wrote them, which is weird. Linus notices. He goes nuclear in his usual way. He accuses Keys of malicious behavior. Says, I cannot imagine any reason for this other than that you're doing something bad. Not just stupid, not just wrong, but that you're actively trying to cause some problem for reasons I can't imagine. And he revokes or tells the person who manages committer privileges to revoke Keys' committer privileges. Now, think about this for a minute. What's really going on here? Why did this happen? I mean, possibility 1. Was it a deliberate attempt to compromise the kernel? Who thinks that's what it is? That's what Linus thought. So you're in good company if that's your answer. Was it a misbehaving SSD drive that was failing? That's what Keys thought, or that's what Keys claimed when he was called on this and said, my drive was having problems. I had to rebuild some things. And Linus just responded and said, that is ridiculous. There's no way a failing drive is going to cause this. Okay. Was it buggy software? Okay, one person going up with a couple people nodding their heads. Here's a possibility. Was it software doing exactly what it was designed to do? It wasn't buggy at all. I'll tell you what it was. It was scope creep. The software that Keys was using to what he thought was managing only one commit back in the history of the Git tree, something called like BT Trails, I've never used it myself, was for some reason changing the names on various commit messages and adjusting the SHA hashes and doing all sorts of other weirdness. Keys did not know this. Linus did not know this. The maintainer of the BT Trails software, who apparently was Konstantin, I'm not going to try and pronounce that last Russian name. So Konstantin said and wrote, "This is one of those scope creep situations. The trailers command started out as a way to apply trailers only to your own curated series, e.g. before submitting a VN+1. But it was then hacked to also work on arbitrary trees without properly considering all possible implications." In other words, he didn't stop. He had software that worked for its purpose and did what it was supposed to do. And then someone wrote in and said, hey, in this situation over here, it'd be useful if we could do a bunch of commits way back too. And that's what ended up happening here. And then he writes in and various other things. Well, if you use these two special command line flags, it'll do what you probably should have been doing in the first place and what used to do by default anyway. The problem was scope creep that the developer of BT trailers did not stop and continued to work on the software. That is dangerous. You want tools that are small and focused, that do one thing, they're clear enough to understand, because remember, Keys didn't understand what it was doing. Linus didn't understand what this tool was doing. These are two very, very experienced developers. The person who wrote BT trailers apparently didn't understand what it was doing anymore. So who does understand it? Now, you had asked earlier about, JPs and Java enhancements. So let's look at the JDK. Now, I'm not thinking specifically about JPs, but just the JDK, we're now 30 years in, as you pointed out earlier. So since 1.0, the JDK has done one thing really, really well and one thing not so well. It does a really good job of freezing things. Almost all the Java 1.0 code that anyone has ever wrote and ever shipped still works in Java 24 or 25 today without change. The pieces that have actually been removed, and those have only been removed in very recent JDKs, like I think they took out the Corba bits, for instance, because nobody uses them anymore. So it does a very good job of freezing things and maintaining a stable API, and that's important. But it often did a bad job at shipping the right things, which has led to, by not getting past the peak of complexity before shipping, as Brian Getz has pointed out. And that means that we've got a lot of problems in the JDK today. It shipped 1.0 way too soon. There was so much hype around it. I was there, I guess Barry was there, maybe Mike, I'm not sure who else, back in 1995 when this was all going on. They were so excited it was going to send Sun stock price to the moon, sort of did for a while, until about 2000, 2001-ish. And they shipped too early and froze things too early, and we got stuck with a lot of those bad decisions for decades, some of them up to this day, like public fields in the point class. Now, that was an obvious cell phone that just nobody looked at it. A slightly more complex one, run type exception is a subtype of checked exceptions instead of the other way around. That one, checked exceptions I've talked about here earlier, on an earlier date, but one of the things I have heard and never been able to confirm is that sometime around late 94, early 95, somebody went on vacation and some other developer snuck checked exceptions into the build, and they stuck there. I think it came in about 1.0 alpha 3. And it wasn't given quite enough thought. I do think checked exceptions are a good idea, they're just not done quite right. There were issues with the toString method in Java 1.0 that severely impacted its performance. And they thought long and hard about whether they could fix that in 1.0.2 because it risked breaking people. And eventually they realized it was also not according to spec in certain conditions, so they went ahead and made the change. A lot of APIs have had to be rethought over the years. HTTP has changed completely for the HTTP client. Networking is completely different than it used to be. We have Java.io and Java.nio. We have the file class and we have the path class, and they really do exactly the same thing. Why do we have two completely different APIs to serve exactly the same function? because they didn't get it right the first time. So basically they said, we can't get rid of file, everyone uses it, so we're going to get this new class called path, and we'll have files and paths and different methods, all do the same thing. And then in the middle of all your code, you have to constantly convert between them depending on whether you're expected to pass a file or path to any given method. It's really annoying. It would be much nicer if they had had a good file API in Java 1.0 that we could still be using today. Object serialization, big problem. Asynchronous I/O, maybe that's not such a good example. That's a case where the changes in the hardware over the decades and what performs well and what doesn't have made a lot of difference as to whether you want to use asynchronous I/O or synchronous I/O in a lot of threads. This is something that seems to flip every 5 years or so. So maybe we just need to keep both of them there. Collections have been screwed up twice. I mean, there was, in the very early builds of Java 1.0, you had things like, I think linked list was there, and I guess stack. I forget what the other classes were, and we did hash table. And then the collections API said, well, we didn't get that right, so I'm going to have hash map instead of hash table. And we'll have these abstract list classes. But even there, they didn't get them quite right because they aren't really read-only lists, and you have all these weird unsupported operation exceptions floating around. Again, they didn't take enough time to get them right. AWT, swing, probably shouldn't have been in the API at all. Assert, broke all the JUnit code that existed at the time. Remote method invocation. And then there are a lot of things that probably shouldn't have been in the core JDK at all. They could have been outside the JDK as standard extensions or just external libraries like JDBC, for example, which is a fine API if you need to talk to a relational database. And if you don't need to talk to a SQL database, you don't need it and it shouldn't be there. This was actually one of the problems when modules were introduced, because it turned out java.sql.timestamp, I think, was being used in weird places throughout the rest of the JDK because it had some nice semantic properties, even if these other parts had nothing to do with SQL. Nonetheless, they depend on the java.sql package. A lot of other things, so they didn't take the time to get it right. Now with the JEPs, they're taking a little more time. They're thinking things through a little better than they used to. That's good. They're still making mistakes. The Java platform module system was an absolute disaster that should never have happened. It doesn't work. It's caused nothing but problems. But they're still pushing it, yes. Lambdas, utter failure, utter, complete, total, colossal failure that a lot of people still like because they like functional programming. They don't understand that lambdas are not functional programming. That's a topic for another talk I will give sometime. But yeah, that was something that shouldn't have happened. A lot of other things. I'm very pessimistic about record types and record classes. Again, Java seems to have a lot of feature envy. They look at some other class. They say they have to have everything that every other language has, rather than focusing on doing a few things well. They tend to chase the new shiny a lot, whether it's annotations, generics, record types. It makes for a very complex language, in my opinion. That's, and if you've learned it one piece at a time over 30 years since 1995, like Barry and me, then you can understand this. But if you're a new undergraduate coming to Java for the first time, it is hopeless, and you go to ChatGPT and you have ChatGPT do your homework for you. And that's why companies suddenly discover that none of the undergraduates who have graduated in the last 2 years can actually write code. At least not in Java. Maybe they can do it in Python. I don't know. So yeah, you have to stop at a certain point and say, we're done. We don't need to keep adding new things just because they're new. Sometimes it's okay to do this. Now, why does this happen? It's fundamentally a problem of misaligned incentives. Number one, it's no fun to not work on a project. You're the maintainer of some, super, well-used open source project. Let's say it's Apache, not to name names, so we'll call it Apache Blackboard. I don't think there is any such project. I am thinking of one particular project, but it's not Apache Blackboard. So you start changing things. You add functionality. You say we're going to use builders instead of constructors. We're going to use factory methods. We're going to use all these fancy design patterns. Do we need them? I don't know. Probably not. And you risk introducing new bugs and new problems into your system. If you are not a volunteer, you don't get paid to not work on a project. If you go to the promo committee and say, hey, in the last 6 months, I didn't change anything. The promos committee is going to say, no impact, maybe put you on a performance improvement plan. So watch out for that. And even if you manage to avoid these two, if you have a project that is completely functional, that works well, and isn't changing, people will write to you and say, hey, is this project dead? I see you haven't committed to it in the last 2 years. I see you haven't released in the last 5 years. Yeah, I haven't released because it hasn't needed a release. But people will stop using it if they don't see some evidence of forward motion. And the other thing that often happens is that new contributors and new volunteers will often come in, they'll suggest a new feature, say, hey, why don't you, replace all your for loops with lambdas? Or why don't you add this new function to integrate your build system with artificial intelligence? And they'll come with a PR ready to go. And if you say, no, thank you, we don't need that, they go away. Because again, no fun to not work on a project. It is hard to just maintain a stable project, fix any bugs that you discover, and not touch anything else. Although that is sometimes what is needed. That was actually something I got very, very clear when I worked at Google on a couple of teams ago. We had very large customers in the, 9-figure a year region who would come to us and say, and when you pay us that much money, you get the attention of the vice presidents, who then come talk to the engineers. That's no fun. Say, what I really, really want, what we need is software that doesn't change. I want to buy your services. I want to write my code, my applications that deploy to Google Cloud, that talk to Google BigQuery, etc. But I never want to have to rewrite anything. I don't want anything deprecated. I don't want anything to change. And that is hard to deliver, but it can be done. Now, are there times you have to change your code? Yes, absolutely. If you discover your code for some reason is not running on the new version of Windows, you have to fix it, whatever is required. Or when it won't run on the new JDK for whatever reason. I've seen a few random bugs on Apache Maven that only come up on like Java 24. So yes, you need to fix those. There will also be changes in the external world outside of your code. We've all been through some of these. You can probably think of more examples. The euro comes in, time zones change. Morocco decides that they're getting rid of daylight savings time with 2 weeks notice. That happened, I think, 2018. New certificate algorithms get deployed onto the internet and the old ones get removed because bugs have been found. Regulations and laws change. Protocols change. HTTP is not what it used to be in 1995. So you'll have to update your code to support that. Sometimes, not always, you can make these details like time zones pluggable, so you don't even necessarily need to change the code to fix them. But other things like, supporting HTTP2 and HTTP3 or new transport protocols, new versions of TLS, yeah, you're probably going to need to make some changes there. So yeah, you can't be absolutely static, much as we might like to. When should you not change? There are a lot of reasons people present for changing code that don't really make a lot of sense. You just want a different API or different pattern that does the same thing. You know, you got constructors that work. I guarantee you, if it's an open source project of any significance, some graduate student somewhere is going to come along and say, hey, we should change all these constructors to builders. No, you shouldn't. You know, builders are needed when they're needed, which is not all that often. Constructors are just fine, especially if you already have them and they already work. Or, you know, decide that you're going to change all your loops to lambdas. Yeah, not worth it. Very rarely are lambdas an improvement, either clarity or performance, especially the only place I ever see where they actually do that is in a Brian Getz talk. Baby Vencat. You know, people now sometimes will send in PRs that remove explicit variable types like int and string and change it to var. Why? What's wrong with int and string? I can't think of anything. I actually prefer int and string to var. And certainly it's not a strong enough improvement to justify a change. You generally do not need to change your own code to take advantage of performance gains in new virtual machines. Hotspot has improved a lot. There's been some amazing work in that over the years in the JDKs. But usually you can run on the new JDK without changing your existing code, or you're changing your existing source code, and still get the benefits of those improvements to things like garbage collection. So I wouldn't worry too much about that. I also would push back very heavily when anyone submits a request to add a feature or support something new to support their own bad practices. So for example, you know, if somebody comes to you and says, your XML library needs to support C data sections, you're like, well, it does, but it doesn't tell me where the C data sections are. That's because you don't need to know it. It's not important. Recently, there was a thread on the Apache Maven developers mailing list. Somebody was complaining that the Maven Clean plugin didn't work because it wasn't removing read-only files that had been put there by an external process, not Maven itself, that was somehow writing into the target directory, where Maven puts all its output .class files and everything it compiles. And after digging down and figuring out what was going on, what was eventually decided was, one, yeah, you really shouldn't be doing that. The target directory that Maven creates is only for Maven's own purposes, and Maven's going to put its own files there. And if you put your files there, what happens to them, we have no concern about. And if you put your files there and you mark them read-only for some reason, we don't want to just go randomly deleting read-only files somebody else put there. So we did not take that request or that PR to implement that feature, fortunately. Another one that comes along a lot is someone will use bad tools like security analyzers to statically analyze code. And they'll send you a PR say, well, we need to change this thing because Joe's Garage security tool says we need to change it, says it's insecure. And we'll point out why it's not insecure in this usage, in this context. And they'll say, yeah, but we have a corporate policy that says we have to be 100% clean when we run Joe's Garage security analyzer. I'm like, that sounds like the problem is your corporate policy. So yeah, I wouldn't take those changes either. You do not always have to chase the new shiny. It is okay to be done. It is okay to stop. It is okay to declare victory and go home. Zom and Jackson, both of them support XPath 1.0 and do not support XPath 1.1, 2.0, or 3.0. Those are good specs that have things to recommend them. Actually, I don't think there's an XPath 1.1. I think they went straight to 2.0. But they work well enough for their own purpose right now. No one's ever really asked for 2.0 or 3.0. Certainly no one has been willing to fund it. So it isn't done. They still work. They're still fine. If I did spend time trying to move them to XPath 2.0, that would take probably multiple years of new bugs before all the bugs were finally squashed. It's not worth it. Similarly, Zom only supports XSLT1, not XSLT2 or XSLT3. Very, very deliberately, it only supports XML1, not XML 1.1. That's a very opinionated decision that no one needs XML 1.1 and nobody wants it. And I think the Last 20 years has shown that I'm right about that one. I've had about approximately 0 requests for XML 1.1, and you almost never see it in the wild. Even less do you see XML 1.1 files that actually need to be XML 1.1 that aren't just somebody changing the version number for no particular reason. The differences are really obscure. Sometimes I do add something. And the enhanced for loop in XOM, this was the last major new feature in XOM. I only did this, Java 5, Java 1.5 came out when, about 2008, 2009? Maybe, was it 2005? I did this around, I don't know, 2018. I did have a user request from a large company that wanted to use this. It was writing code using XOM. That large company happened to be my employer at the time, so they got a little more attention. It wasn't just, I think this would be cool. I tried to limit the impact. I only made this change, only added support for the enhanced for loop via the iterable interface in the 2 most obvious cases where it fit best. I thought about adding it to some other classes that were a little less list-like Element, but there were some concerns, so I just started small and simple. This actually solved everyone's needs who wanted it. And then finally, things that aren't changes. These are things that don't qualify as changes, but you may need to do them anyway. If you have to move to a new source repository or a web host, just do it. That's not a code change. I don't worry about that, although it's painful. For some reason, source repositories tend to die. Anyone here used code.google.com? You should put a finger up. Put a finger up if you used code.google.com. Put a finger up if you used java.net's source hosting. Put a finger up if you use SourceForge. I don't know when GitHub goes away, but I suspect it will be within the lifetime of some of us sitting here. For some reason, source repositories just sort of die. It's not a business model that works. You can always edit, add, rewrite your documentation, improve it. That doesn't change your code. That's fine. That's not risky. If you're careful, you might change the build system. You might decide Ant doesn't work anymore. I'm going to use Maven. I don't. I actually still use Ant for XOM. Not sure if anyone else in the room is still using Ant for anything.
Still have to build that XML file to solve my project.
Yeah, so you can do it, but I'd rather just keep going with the thing that works. You can usually use an upgraded compiler. Occasionally, it'll give you a few new deprecation messages, or it'll say things like, hey, why are you still trying to compile for Java 1.5 in 2025? Please stop doing that. So yeah, that might be a problem. Java is actually pretty good about this compared to most other languages. Most other languages like Python have a lot bigger problems as you move from one version of the language to another. So this is one where Java stands out. And why are we stuck suddenly? Okay. And with that, discuss. Yes, Mike.
So I was at QCon London back in April, and John O'Hara, the father of AMQP, gave a great keynote. I was surprised to learn that AMQP 1.0 spec was released in 2011, and I don't think it's been upgraded since. It was that. I guess this is a good example of get it right, and stop.
Yeah.
But what are your thoughts on it? Because he went into the whole thing about how AMQP involved and the whole thing going back to like 2002 or something like that. Yeah.
Different than programming languages. I'm not familiar with AMQP myself. If you think about something like JSON or something like XML, JSON has evolved a little bit, but not very much. XML, hardly at all. 1.0, they've rewritten the spec a few times to clarify some points. But it's essentially still the same language it was in 1997. And very few actual changes, if any. So if that's the situation, it's really important to get it right because you really, really want stability even more than in a programming language. But yeah, AMQP specifically, I just don't know.
Yeah, I learned some new things about that too. because I really haven't done any much with messaging at all. But I thought it was a great keynote, and the struggles they went through. We do have a question from Boris, who's not here tonight. That's right. So he's online, and he said, "Would you still recommend using XOM for XML processing? Java now has standard libraries for that."
Yes, I still recommend XOM. It does depend a little on what you're doing in the context. The standard libraries Java has are essentially sax and DOM and stacks, which all existed before they were incorporated into the JDK. Sax is very good for certain purposes, especially if you need streaming processing with high performance and high throughput. DOM is an absolute disaster that, whose failures led to both JDOM and XOM and other things being created to replace it. And it didn't get any better just because it was put in the JDK. The benefit of using DOM, though, if you can stomach its problems, if you're really an expert on it, and you know things like how to manage namespaces in DOM, which is far from obvious, and how to set up your document builders and document builder factories and all that other document builder factory implementation factory builder classes, as Java is infamous for, is that once you've done that, you don't have an extra third-party dependency. So if you're doing something simple and you're doing it once, you might want to just use DOM if you're very comfortable with it, because then you don't carry around extra dependencies. But if you're doing a lot of XML processing work or you are not intimately familiar with the idiosyncrasies of DOM, then you would probably be a lot happier using either XOM or JDOM.
I remember Sax and DOM. I remember,
But one of them was it read in everything incrementally. The other one sucked in the whole.
Right.
Yeah. Okay.
Sax and stacks. Sax is I want to say, a push parser, and stacks is a pull parser. They are both streaming models, so you receive the parts of the individual document one at a time and process them, which some people like, works well for some applications, doesn't work for others. DOM and XOM and JDOM are all more tree-based models where you suck the whole document in, assuming it's small enough that it can fit into memory, and then you have it and you can query it and run around in memory and go from one end to the other very quickly without building up intermediate data structures.
amazing how it came back.
Yes?
Comment on
Go language. Can I comment on Go language? I've honestly not done more than played with it, so I'm not really.
So I tried to ask a trick question from the point of view of one of the selling points of Go is that it gets away from all of this piling on of history, such as you went through with JDK, and JavaScript had similar problems.
Right.
But for, I suppose, a lot of people in this group who are locked into big organizations with a lot of legacy Java code, I sent Mike an article from, I forget the name of the guy who invented Java a long time ago.
Gosling.
Yeah, James Gosling.
I thought you were being facetious.
He bailed on Java and in this article and is doing everything in Go from the point of view of one of the developers of Go, Rob Pike, was talking about the stop principle, where C++ and Java are always adding on shiny new features, and it becomes impossible. So now that you're semi-retired, I'm teasing you a little, but you might want to consider looking into Go seriously.
This will all happen again. Those of us who are around 30 years ago remember how Java was presented as the anti-C++, how it was an object-oriented C-like programming language. It was much simpler than C++, and it could actually be taught to students, that it did not have all the weird corner cases and special edges of operator overloading and templates and every other and preprocessors and whatever else that made C++ the monstrous beast that it was at the time, and it's only gotten worse since. Now we're looking at it, and that's how people look at Java. And now you're telling me, okay, let's go look at Go. It's simple. It doesn't have all this stuff. Go is what, about 10 years old now? Yeah, I mean, let's see where Go is in 20 years. If it doesn't go anywhere for 20 years, if it's more of a no-go, then I will believe you. But there is
stuff to go. Like they just added generics. It's going to be as big as Java at the end.
A lot of this is about what is the core fundamental principles of the language. So in a language like Haskell, it's functionality. In a language like Java, it's object orientation. In Go, I'm not sure, but maybe systems programming. I don't know. The problem perhaps arise when you lose track of your language's fundamental core, and you start saying, well, we're going to be an object-oriented language, and we're going to be a functional language, and we're going to be a generic language. Now, I hope Go avoids that. I can't say I'm optimistic.
Ints versus varchars or strings or something like that. And the world I came from didn't have any of that type safety at all. And for the longest time I was saying this is all ridiculous. But the thing with Go, the selling point is that everybody needs is speed and multiprocessing. And by having strong typing, then what's in memory is controlled and not loosey-goosey. And
Go does have some nice features that Java does not, that Python does not, including things that make it very fast. It does compile to a single binary. It doesn't have this, issue with class path held and dependencies and virtual environments that you get into with Java and Python. So that's nice for systems programming. At the language level, again, I haven't worked with it enough to really be familiar with it. I don't know how its performance in practice compares to, C++ these days. If you really want to do super fast things, if you want to multiply very large matrices or something, but I'm sure some.
Bash Python. I think indenting 4 spaces and writing code like that is just so bizarre and crazy that it should be mentioned in a college or.
Python is what everyone coming out of school seems to be using.
Understood.
I will say, the question you asked, I've heard many times over decades now. Of, is Java going to die? And it doesn't seem to be. It seems to maintain its stability and popularity, but it does seem to come up all the time, always.
Yes.
It doesn't seem any major programming languages are going away, but some do fade out over time. There's not a lot of COBOL left in the world, but it's there. There's not a lot of Fortran left in the world, but it's there. There's not a lot of AppleScript left in the world, much less successful originally. There's still a lot of C++ out there, and you can still find jobs doing C++ and C, I suspect. Ruby seems to have peaked. I don't know why, but it never, I think maybe for everything except Ruby on Rails, Python seems to have taken its place. I don't know why that is. I've never worked enough with Ruby to really be comfortable judging that. But
Barry wrote a book on it, and then it was all over.
it's your fault.
He's right.
I changed the version from 1 to 2.
graph of the peak varies?
Oh, small talk, yeah.
Yeah, that's the way it worked.
So Boris mentioned, he made a comment, he said, I used to do small talk in the 1990s. It's practically dead now. So I mean, it's still out there, right?
Yeah.
Just like, yeah.
Another one that was probably bigger than small talk, but also I don't know if anyone is still, there must be someone somewhere, but it would be hard to find them using Pascal. That's maybe the biggest language I can think of that really does seem to be effectively dead at this point in time. You know, there are other languages that never quite achieved liftoff, you know, where so many of them, Modula 2, Modula 3, Eiffel, Snowball, Ada, yeah. Yes.
So you mentioned before stuff like YAGNI and avoiding third-party dependencies. I'm kind of curious to what your opinion is on stuff like using like massive frameworks like Spring Boot, like that brings in the whole kitchen sink and all that stuff.
Yes.
Could easily be a talk in itself. My take on third-party dependencies is use them if they're doing something complicated that you either can't reliably do yourself or that need a real expert or that would take a huge amount of effort to do yourself. So for instance, if it's if it's cryptography related, for example, you want an expert. I would use the third-party framework. I would not write that myself because I would get it wrong, and it's really hard to get it right. If it's something simple, like I've seen people pull in Guava or Apache Commons collections because they need to split a string into parts or they need to capitalize the words in a string or something. That's trivial to do yourself. You don't need a special library just for that functionality. And where does things like Spring fit in? I will say this, I have never effectively used those packages. I've never effectively used Java EE, and I have seen inside very large tech companies doing very large applications, and they aren't using them either. So I'm pretty sure they aren't. Now, some of that is because they have very idiosyncratic tech stacks with things like Big Table that they're sitting on top of that are not out there in the rest of the world. So they have to have their own tech stack that essentially replaces Spring in some way, shape, or form. But it does seem to me that a lot of these things, certainly Spring was supposed to be the lightweight alternative to Java EE, if I recall. You know, and Hibernate was the lightweight alternative to, I'm not even sure what, JDBC maybe. Depends on what you're doing. I would generally try to see if you can make things smaller and make them out of smaller pieces. But it depends on the application.
That makes sense. Like a lot of developers I talk to, they can't do a thing without Spring, right? You guys can make a basic API call, for example, inside like a AWS Lambda, something that needs to be lightweight. They have to bring in all the Spring Boot just to make that one API call.
Yeah, I personally tend a little more toward the other extreme. You tell me to make an API call, I'm looking up, you know, the specs for the API so I can use java.net.http URL connection to ping it. And then maybe if I'm feeling lazy, I'll use Apache HTTP client instead. But that's me. There's probably a happy middle. I actually had to do this a couple of months ago as part of a rather extreme job interview I promised not to talk about. So I can't tell you too much about the actual project I was doing, but it did involve using an external third-party API for something. And I looked at it and said, well, I could make direct HTTP calls to this, but then I have to figure out authentication and authorization and token handling and API keys and all this other stuff that I have to stuff into the headers. So I went looking, and yeah, there was a reasonable client library for it. Similarly, if you look at any of your Google Cloud Platform client libraries, for Google Cloud Bigtable or Google Cloud BigQuery, there are Java-based client libraries and Python client libraries that will make this somewhat simpler, and I would use those for talking to those services, even if I did not use a huge framework like Spring to put it all together. You know, they just pull a lot of the pieces together, especially when you get authentication and authorization into the picture. Life gets really complicated really fast. Okay. Yeah, question in the back.
I know you mentioned this was a subject for another talk, but what did Java get wrong about lambdas, or why? Because I've seen lambdas used. I mean, it's not like I don't see them in the wild.
And almost never is the lambda more clear, or and almost never is it not less clear than the equivalent for loop. That's my first problem with lambdas. It's a bad syntax. I like functional programming. At one point in time, I could legitimately be claimed to be one of the world's top 5 experts in one of the most successful functional programming languages and purest functional programming languages ever. That's XSLT. But Java didn't do it right. They came up with a ridiculous syntax that is nearly indistinguishable from line noise. That's problem number one.
Well, they shoehorned it inside of it.
Yes. And they also shoehorned it inside an object-oriented language, and those are two very different paradigms of programming. And it's not clear to me they should be part of the same language. If they are, then you need to design classes and objects that are immutable fundamentally. And Java doesn't have that. Java is based around mutable objects, which maybe you make immutable for reasons of thread safety and other things, but that's not baked into the language. There are other problems in integrating Java with functional languages. Nothing in Java is a purely returning function because everything conceptually can throw a throwable. If not a checked exception, then a runtime exception. If not a runtime exception, then an error, like an out-of-memory error or no class def found error.
Because then you see code with try catch blocks inside of lambdas, which is
And then
horrible to read.
And then they throw, and then they either ignore the checked exception or they convert it into a runtime exception. And again, it doesn't fit into the language. And it doesn't make the code clearer. It usually makes it more opaque. It's usually harder to understand. It's harder to debug. It's harder to step through when something's going wrong. And
Do you have any does method references affect that, like that opinion? Like, do you think method references are better, worse, or the same?
other ways functional programming could have been done, much like generics, they oversolved the problem. With generics, what people really wanted and needed was a way to say, this is a list of strings, not just a list. This is a list of ints. And they didn't actually give that to us because of the primitive object type dichotomy, so you can't really have a list of ints. You can only have a list of integers and hope things auto-box the right way. And then with lambdas and method reference, what people really wanted, I think, was just a way to have, pass a method to a function. So like, say you have a sort method, you want to pass a compare function in. That's it. That's all people really needed or wanted. And instead of getting that, what we got was this huge pile of line noise I can't decipher.
So them could be unreadable for some of them.
Yeah, I still have, I'm getting better at it, but I'm still trying to figure out how to read a lot of the generic signatures.
So, again, people want a list of strings. They don't want list question mark extend string list question mark super string. What's the difference between super and extends? There's the PEX principle, which Josh Block wrote about. Again, it's overly complex for what people actually wanted to do. And I think lambdas are similar.
Sorry, Barry, it didn't run down.
Okay. We've got this sort of MIDI shotgun mic, so it should be okay. Other thoughts, questions, disagreements, comments? You don't have to phrase in the form of the question if you want to tell me I'm just wrong about lambdas. Okay. I guess that's a good place to stop. Mike, I think you had other things you wanted to talk about?
Yes.
No more more questions? No, there's nothing on the chat. So first of all, let's thank Elliotte for his time. It was awesome.
Thank you.
So yeah. All right. So as we do upcoming events, InfoQ Dev Summit Boston. Today was the last day, but I thought I'd put it up there for completeness. Compared to QCon conferences, these are only 2 days as opposed to 3. They're a bit smaller, so that just wrapped up. Next week, this kind of all came out within the last week and a half. The Sul Java folks, as you know, one of the biggest Java groups in Brazil, is having a celebration week for 30 years of Java. And so all of next week, they're having a series of talks. And I talked about, I recommended, hey, let's do a retrospective panel, on the last 30 years like we've seen in some of the other conferences, and they thought it was a great idea. So, as it turns out, Bruno Sousa, Barry, and myself will be on that little panel, I think a week from Thursday. And I'm going to debut a talk named, let's see, getting started with Jakarta EE11 and what's new in Jakarta EE12. So I'm wrapping that up and getting that ready to go for next week, but that should be fun. There's a whole bunch of great speakers. So this is all virtual. So you can go to that website down there. Kansas City Developer Conference, or otherwise known as KCDC, is in mid-August in Kansas City. So if you're looking for some great barbecue and out there, there is a discount code, as you can see, GSJUG10. I thank Billy Carando for providing that for us. Dev2 Next. This will be the second year, and this is Venkat Subramaniam's conference. And this is in Colorado Springs. And just like with the Arc of AI conference earlier this year, Venkat's going to be doing raffles for free admission in the months of July, August, September. I think that's what it is. And so during our conversation with that, I said, hey, Venkat, when are you going to be in New York City? Maybe you can make the tour of us, New York, JavaSig, Philly, and all that, right? So he said there may be an opportunity if he's going to visit a customer out there. So stay tuned. Hopefully Venkat will come visit with us later this year. That would be awesome.
Real quickly, we do have some leftover pizza, cheese, and I don't know what that is,
Cool.
but just if you want to grab some pizza before you go.
Yeah. So that's that conference. So instead of a discount code, there'll be raffles for free tickets. This is also something relatively new. Richard Fitchner from the Jug Oberpfalz and the JCon creator, they're going to be part of the IBM Tech Exchange in Orlando in early October. So there's a 30% discount for that if you're interested in going down to Florida for that time of year. I guess it's a bit cooler. And then the InfoQ Dev Summit Munich is October 15th through 16th. QCon San Francisco in mid-November. And the whole New York QCons has changed. This is QCon AI New York. This is in mid-December in Manhattan. So stay tuned. It's 2 days, I believe, for that. So yeah, that should be fun. So, and there's others. There's all the DevOps out in out in Europe and all that. So I'm sure I've missed a couple. Okay, upcoming events for us. 2 weeks from tonight, testing Gen AI applications in Java with test containers and Docker. Anna Chernyshova will be here, and then she's with Docker. So, so yeah, stay tuned. I'll update the website and obviously send emails, the whole thing. And then in July, you already know that Billy's going to visit with us, Philly and New York, and I think even DC. So he'll be here on July 9. And I just got the abstract within the last 24 hours. Somebody from Hazelcast will come out on July 15th, and I think Barry was checking on the on the availability of this meeting room.
I was?
I think you were. I
Oh,
thought you said
okay.
you.
I was.
So anyway, we're tentatively set for July 15th for that. Let's see. And then in September, we have a doubleheader. So it is baseball season, right? So Vlad Shipilov, right? Did I call you the wrong name earlier? I did, didn't I? Sorry. Was that? No, your first name, didn't I? Yeah, no, but I thought I called you something different. I don't know, but anyway, if I did, I apologize. So, you know, this is the, you know, getting older is not, you know, yeah, anyway. So Vlad's going to be talking about Apache Spark and Databricks. And then Alok Tibrawala will be talking about LangChain 4J. So this is both on the same night. I think, Vlad, yours is a bit shorter, about 20 minutes or so, if I remember correctly, right? And then we'll have Alok after that. So that's where we are with us for the next couple of months. And, you know, we're going to see what we can do to finish out the rest of the year. So as Barry well knows, back in the old days, we used to fly off the seat of our pants half the time, you know, to try to come up with the topic. So this is a good problem to have.
Right.
So anyway, friends of JS Jug, you know, I usually talk about what they're doing this month. Unfortunately, I didn't get a chance to really study what they're doing, so I didn't update that. Apologize. But you know, if you do the usual meetup, you can see what they're doing. So. And Pete Bisbal won the IntelliJ idea last month, and so of course I'll do the raffle the next day or so for this month. So yeah, so we're all caught up there. Oh, and then I have a resources page. I think at some point, if you know you guys want to take a look at this, it's at these slides especially for the links. It's our URL/reveal.js, and you can see them there. So I put some resources about the Future Directions group that myself, representing the Garden State Jug, we're a member of that to talk about the future directions, of course, of Jakarta EE, and then the Jakarta EE ambassadors. So. And that's it. So for those of you out there in television land, if you want to please scan the code for signing in and to get your name in for the raffle. Also, for those of you who are here, you'll see a couple of sheets of paper with the QR code. If you wouldn't mind signing in for attendance, you know, I do keep track of that. This kind of goes back to the old ACGNJ days. So, but anyway, yeah. So.
Mike can tell you who showed up at the ACGNJ meetings in December of 2005.
I just have to.
We don't need to say it like we're.
Yeah, no, I didn't say I was going to do it. So, but yeah, no. So in any event, we'll see you here in 2 weeks. For myself personally, this would have been my dad's 90th birthday on June 24th. So, so yeah, so we'll remember him and. Yeah, thanks for coming out. I know it was a beautiful day today, and we appreciate you supporting us. And if you guys have any topics, just come up to us and talk to us. Or I think Alok and Vlad, they came to us and said, "Hey, we want to present." We love hearing that, you know. So thank you, by the way, for that. And with that, we'll see you in 2 weeks. Oh yeah.